So we're now being recorded. Thank you very much, everyone, for coming along. We will follow the normal Zoom etiquette rules. I'd ask you to keep your microphones on mute and your cameras off, please, unless you're speaking. I'm sure Mohan will be happy to take a few questions at the end, but equally, if you have questions as he is talking, then please do feel free to put them in the chat and I can share them with him afterwards. So with that, I will just introduce Mohan, who almost needs no introduction. So Mohan has been at UCL for a long time now, and his work in the development of biomaterials for healthcare is renowned around the world. So slightly more officially than that, Mohan is the Bonfield Chair of Biomaterials here in UCL in the Department of Mechanical Engineering, and he joined us from Queen Mary University back in 2005. So Mohan has more than 500 journal papers, an H-index of 64, and many thousands of citations. But also beyond that, he's been very successful in mentoring PhD students and postdocs through their PhDs and into independent careers, and also delivering impact in the form of spin-out companies and things which can genuinely be used to make patients' lives better. And that's won in prizes including the Royal Society Brian Mercer Innovation Award 3 times, the Materials Science Venture Prize, and the President's Prize of the UK Biomaterials Society, to name just a few. So with that, I will hand over to Mohan. Thank you very much for your talk, Mohan. We're very much looking forward to hearing from you. Thank you.
Thank you very much, Gareth, and good afternoon, ladies and gentlemen. I'm very pleased to give this talk. I do not know how novel electronic conferencing is, but it's sort of gathered pace since the pandemic. And as Gareth kindly said, this is a talk that I was invited to present at the first International Electronic Conference on Pharmaceutics 2020, which I think is scheduled for next month, early next month. So when I was asked to talk at this conference, I automatically decided to make advanced manufacturing research for healthcare my topic. And the reason for that became very apparent during the pandemic because we had so many bright ideas we all have at the laboratory level. But to translate things to manufacturing, whether it be masks or whether it be PPE or some other more involved form of manufacture for healthcare, we became unstuck because we had to go out to the world to get these components. When we both had the science and the kind of technology, that has been developed over a wide number of years. But we had come to the point where we didn't have the mechanisms to scale up the actual manufacturing to suit the problem. The work I'm going to describe today has a major contribution, and I stress the word major, from the School of Pharmacy. There have been lots of collaborators. So although I am speaking today, portraying this work, I think it's very important to note that the collaborators have played a big role, like Professor Duncan Craig, the head of the School of Pharmacy, who has really given me all the support during 2 EPSRC-sponsored projects. So I will start first by using microbubbles as an advantage. My laboratory, which you can see from the previous slide, you can log in there, www.idrissingalab.com, will give you more details. I can cover only so much in half an hour. But microbubbles, both for actual imaging, contrast agents in ultrasound, and also for drug delivery, has been a key topic. And a lot of contributions have been made by my team. Particularly, I like to mention Dr. Mariam Pariska, who's now a lecturer in SOP. And we were invited by Langmuir to put this all together in a special issue. and they called it Microbubbles, a New Medical Frontier. Now, a lot of work has been done. There were 24 key papers by key leading researchers covering every part of the world. I'm not going to summarize all that. I'm going to be giving you a few slides on how this work has progressed in the recent months. Since the laboratory opened, and even a bit before that, in the last 3 to 4 months, we have been sort of concentrating on one method, which we think is the method that's going to take microbubbles into industrial production. What you have to look at in microbubbles is both the size, if you want to use it in biomedical